Long time no see. So I'm gonna get straight to business. I'm not in any pain right now, which is great. It's like the second day in a row I haven't had any pain, so I mean, it's the only reason why I can do this right now. But what I wanted to do is just make our notes pretty quick today. Because I don't know how much energy I actually have right now to do it, but it should only be a few minutes. There's only 4 examples, and it's a relatively easy concept. When I do hope to return on Monday. So if you do have questions on like the difference in the sum of two cubes, that's good. That's fine because that's kind of one of the harder ones. It usually takes 2 or 3 days. I would just say keep working at it, and we'll go over it on Monday before finals. Okay. So this will be definitely on your final exam. This topic that we're going to go over right now, and it's called factoring by grouping. And what I want to do real quick is just kind of go over this little tree here. This is very rudimentary. Kind of jot it down real quick. I just want you to understand that there's avenues that you have to take in order to factor polynomials, and that includes quadratics. That whole chapter we did last unit 2 was all on quadratics, and we kind of stuck around right here. Sometimes you'll have quadratics. Well, obviously you'll have the 2 squares right here. So you'll have like quadratics here. But polynomials is a much bigger topic. Quadratics is only one type of polynomial. And so what's got to happen then is polynomials are here. And if it's not a quadratic, then you're going to have to use other avenues. And this took hundreds of years to figure out. This guy right here is probably the trickiest business, called the rational root theorem. We may or may not get to that. I don't know if I've ever seen it on the SAT. So I'm kind of the philosophy that we might not do it. Okay. Let me move this mouse here. All right, so so what we're going to do today is grouping. You'll notice that the qualifications here is you needed 2 terms to work what you were working on, 3 terms to do the X method and the AC method, but 4 terms is grouping, and that's it. Like, if there are 4 terms, you can only group, and if it's and you can only group if there are 4 terms. Okay. So let's see how we do that. Otherwise, you cannot factor it, and you would just say unfactorable. Okay. So let's go ahead and title this grouping. Okay. And hey, Atticus, can you give me a better marker here? Maybe this marker would work. I just need see if you can give me a dark marker. I appreciate it. All right. So grouping is only going to work. Is that too faint? Yeah, it's a little faint here. Did you find one? Okay, perfect. It's a dark one. Okay, thank you. All right, so grouping is factoring. Okay, with 4 terms. Okay. All right, so what we do is we've got, let's say we've got this guy with, I've got 4 examples written down to show you the extent of what you will experience on the SAT, and it wouldn't go past that. Even in pre-calc, like there's only maybe 1 extra layer that you would do with grouping, okay? Now here's the best way to handle this. When this is in 4 terms, what we do is I like to draw a line right down the middle to split them as 2 separate things, right? And what you do is, in order to see if you can group, okay, there's got to be a special situation for you to group, okay? Now, if you notice that this is an invisible 1 here, this is 1 to 3, okay? And what you want to do is just say 1 to 3, is this also 1 to 3, okay? Is 2 to 6, is that the same as 1 to 3? And when the answer is yes, you can group. Now, the examples we're going to do today are going to be grouping, okay? That's going to follow. But sometimes you just say unfactorable. If this 6 happened to be a 7, this would be unfactorable. All right. So what we're going to do is, what you do is you find the GCF of each particular piece. Okay, that's all. Of each particular half, I should say, right? Because we cut it right in half. So let's find this. And when you look here, you'll notice that it's just x squared that they both have in common, okay? Because this x to the third actually has 3 x's, two of which to spare. And the 3x to the second power, you can take out 2 of those. Nothing else, though, okay? So what we do is we close this up with parentheses, okay? And what we do is we go ahead and say, well, if I took out 2 of those guys for this guy, I'm left with x. Okay, I'm going to zoom in a little bit here. Okay, and then if I have a 3, that's the 3 is actually the only thing left. So I've got x to the 3rd. Okay, now what I do then is I just leave that sit right there and I focus on the other half. All right, so what I do is I'm going to look at, see what I can take out. Okay, now this is only 1x, this doesn't have any, so it's not going to be an x anymore, but I can definitely take a 2 out of those. Now it's going to be a positive 2, so I'm going to put a plus 2 here, okay, and basically do the same thing I did over on the left hand side. So once I take that 2 out, I get an x, and with that 6, I get a 3. Okay, now here's the cool thing, is because both of these guys have an x plus 3, we can factor that out. Now so I can actually factor an x plus 3 out of this entire term. I can take it out because he's a bundle, okay? And then I can take out an x plus 3 out of that too. So what's left here, okay, is these guys just become one parenthesis out here in the front, and whatever these guys are that we took out become its own parenthesis. Okay. Now, technically what you did is you factored out an x plus 3 out of both terms. Now, it doesn't look like these guys are terms, but there is only 2 terms here. Okay. These guys are being multiplied together. Okay. And so this is one term, this is another. So what I did is I took an x plus 3 out of both. Okay. And if that's hard to kind of understand, you're not the only one, okay? What you basically do, if you want to look at it in another light, and this is usually how I kind of explain it, just all you got to do is just cross one of them out, okay? And then just make sure you loop around the other parenthesis. And this parenthesis and this parenthesis is all you need, okay? It's that simple. Technically, again, you factored out an x plus 3, but, you know, if you want to look at it like this guy here is one parenthesis, this guy right here is the second, okay? But these guys can go in any order that you want. It doesn't matter, okay? But that's factored. And it's impossible to do this any other way other than grouping, okay? All right, so let's look at another example here. Okay, so this one's got a little difference to it. We got 6r to the 3rd plus 14r minus, squared, 15r minus 35. And notice that the degrees have to go down in order too. Like this, for grouping to actually work, you've got to have the right conditions, okay? So now we got to ask, is 6 to 14 the same as 15 to 35? This is, if I divide both of these by 2, 3 to 7, divided these guys by 5, that would be 3 to 7. Okay, so 3 to 7. This guy can use grouping. So look at the GCF. I can definitely take out 2 R's, and I can take out a 2. Okay. So that leaves me with 3R plus 7. Okay. And just you can backtrack just to make sure you did it right. This times this should equal that. This times this should equal that. All right. And if it doesn't, then there's something else you need, okay? All right, now over here, though, you'll notice, though, that I can take out a double negative, okay? Sometimes you might have to take out a negative while that is positive just to make these guys match, okay? These guys have to match in order for you to scribble it out here, okay? They have to be identical in order for this thing to work. So over here, I'm going to take out a negative 5, and I will get a 3R, and then a plus 7. Because I took out the negative sign, he'll become positive. And notice now that they completely match. So you can just think of it very simply and just one parenthesis. Let's put this guy in front this time. Doesn't matter. And we'll put the 3R plus 7 there. It's factored. That's simple, okay? Okay, so what's another thing that can show up? Like we only got 2 more here. What are we at? Almost 10 minutes? Okay, no problem. This gets quicker as you go. Well, let's make this another x, 7x. Oops, that should be a 2. I'll talk to you guys like why I went into the hospital and everything. I'd rather do it in person rather than over video and kind of explain what's going on with all that stuff. And definitely when I go return, I'll definitely have to be in a wheelchair. Not only just I can't fall again. It's just pretty, it's detrimental. I do not tip over ever again. All right, common factor here. Let's see, we got 7 to 56. Okay, that's a 1 to 8, and this is a 1 to 8. Now it looks like we got a negative here. And a positive. So let's pay attention to this. Let's take out the GCF. We'll pay attention to that in a second. But let's take out the GCF. That's going to be a 7, because 7 times 8 is 56. And then I can take out 2 of these x's. Okay, so notice that we're not dealing with quadratics anymore. We're dealing with cubics, right? And when I do that, I've got an x here, and then I've got minus 8. So what I need over here... Oh, wait, I'm sorry. I changed this from... Should be x. What I need over here is an x minus 8. And notice that that's exactly what I have, is an x minus 8 over here. So here's the thing. What you want to do is pretend you're taking out a factor. And technically, you really are. What I can do is, if you see exactly what you need, just pretend to take out a 1, okay? So that this actually is x minus 8. Now, the reason why we take out a 1 is so that we can do this little trick right here, okay? With that 1 in front, you'll know that this guy plus 1 is going to be one of our parentheses, okay? So again, cross it out. And we got a lasso. But notice I had to take out something, right, in order for this process to work. And so that something is a 1, okay? And then you got an x minus 8, all set, okay? All right, this guy's done. There's nothing else you can do. Now, what can happen is sometimes these guys can be the difference of 2 squares. Very rarely are they the difference of 2 cubes, well, because you're factoring a cubic. So sometimes that can happen, but that's very rarely, okay? This is our last example, because really there's nothing else that kind of comes. I'm going to actually do it like this here. There's nothing else that's really weird with these. These are pretty straightforward. And on the SAT, they're very simple. Like they're very basic. So I'm kind of giving you the more advanced stuff just in case they overreach and throw something at you ridiculous. I don't want you to think that it's hard. It's just you got to remember that this is the process. Okay, now I've switched over to the variable k. Doesn't matter. And you'll notice, though, that these numbers are quite large. So is there something I can take out of all of them that would allow me to do this? Is it any? Let's see. What is this? Take out a 5. 2, 3. Oh, 3. Okay, I can take a 3 out of all of it. Okay. So sometimes there's a GCF, and that's actually why I want to do this problem. So let's take a GCF of 3. Okay, now he's going to go on. We're going to attach him at the very end. Okay. Okay, 3 goes into 45 once, 15. Minus 8k, minus, and that's 12. Okay, now we're right back to normal. Okay, just remember that once we get those other 2 parentheses, that 3 is just going to sit there. Okay, so he'll be there for us. He'll just be right there, attached on. Okay, I'm going to do this real quick. Okay, now I can take out a 5. So the 5k squared is a 2k plus 3. Now I need that 2k over on the other side. So over here, I'm definitely going to take out a negative, and it's definitely going to be 4. Okay, and then if I took out a negative 4, that's 2k, and then a positive 3. And that's exactly what I needed. I've got twins, and so now 2k plus 3 can go in any one of these parentheses, but I'm definitely going to have a 5k minus 4. And then that's this group. Okay. And then 2k plus 3 is right there. And that is grouping, okay? All right, so you got an assignment in Google Forms, and I think it's a Google Sheet. So do that. That should be a quick one because you've got choices, and then there's a worksheet after, okay? And I might need some extra time on the other one. I doubt it, but we might work on this like another day. I'll just kind of need some feedback. All right, and let's see.